Welcome to solverfy.
.22, we have this setup of two coherent light sources that are in phase with each other and emitting light at some wavelength lambda. We find that there's 30 points of zero intensity, minima, dark fringes, whatever, in a complete circle around them, including 2 on the x-axis on either side of the sources. And we want to find out what the ratio of d over lambda is. So I've gone ahead and written down equation 35-16 here for the minima. We'll be referring to this a little bit. So first we need to think a little bit about the sort of what this looks like and count some things, and that'll help us figure out what to do. So if we put in a y-axis here, first of all, there can be no minima on the y-axis because these are in phase with each other, and so the distance to any point on the y-axis is going to be the same for both, and so they're going to add constructively. So there are no minima here. We know that in each half of the plane, we have 1 on the x-axis, and so there'll be 7 in each quadrant, sort of evenly spread around. So in the if we begin at the counting them at the y-axis and going clockwise, say, you get m values, and so we get, because this is going to be the central bright fringe, and we basically just count along to find what the m is for the points on the x-axis. And so this will be m equals 7. And so this corresponds to a theta of 90 degrees in this equation. So we have d sine theta is 1 at 90 degrees, because the angle is measured relative to our y-axis here, is going to equal m, which is 7, plus 1/2 times lambda. And so then this implies that d over lambda is 7.5. So this is a little bit tricky because we have to sort of think about this is equivalent to a double slit experiment. If you just ignore the bottom half plane, for example, because each point source behaves like a slit, or rather, each slit in a double slit experiment behaves like a point source. And so then thinking backwards from that is how we can arrive at m equals 7 here and then get our answer.